Okay, so let's move to some other, maybe more interesting to you kind of applications of the fundamental counting principle. Okay, so here's one that I enjoy. How many different colors can your cell phone show you? Okay, and not just cell phone, but also any computer, a TV, anything that uses what's called an RGB or red, green, blue color system. So real quick introduction to this. Red, green, blue, RGB, any color that's on a screen, like your cell phone, has three color components to it: red, green, and blue, RGB. By combining different numbers of these component pieces, different levels of each one, you get different colors. For example, let me just show you. The three primary colors, as I just mentioned to you, are red, green, and blue. Now, some of you are going to say, wait a minute, I don't use those when I paint. When I paint, for example, I sometimes mix blue and yellow to get green. And I totally get what you're saying. There's two different ways to mix color. One of them is how paint mixes, and one of them is how light mixes. And I'd be more than happy to demonstrate this if we ever have time. I've got some flashlights up at my office, which I'm not at right now to make you a video to show you, but I can demonstrate for you how to mix red and green together. If you mix pure red and pure green together, you get yellow in the visible light spectrum. I know some of you don't believe that because you don't mix paint this way, but I'm not talking about mixing paint this way. I'm talking about mixing light, which is a different kind of mixture. If you mix green and blue together, 100% green, 100% blue, you get what's called cyan. And if you mix 100% blue and 100% red, you get what's called magenta. Now, you might notice these three colors. If you've ever changed the color cartridge in a printer, you've seen these three. These are the three colors that are mixed together to make other colors in a printer. That's because printer ink works like paint. Light, however, works like light, which is very tricky because you don't paint with light, you paint with paint. But don't worry about that. That's not the important part. The important part is just knowing that they start with three colors: a red component, a green component, and a blue component. Now, here's the thing. If you mix 100% red and 100% green, you get yellow. But what if you mix different amounts of red and green, or different amounts of green and blue, or blue and red? For example, what if you vary the blue and make it half, or vary? Well, we'll get into that in a second. Here's a partial listing of all the different hues you can get. Now, if you look through this, you definitely see some rainbow colors. You see some oranges, some reds, some yellows, some greens, some blues, some magentas over here, some blacks and grays down the bottom. And that's every one of these little rectangles is a different color shade that you can get. So what I want to do now is I want to kind of explore that with you. So what I did here, and I gave you the web link here if you want to mess around with this too. I'm going to do it for you here on the video. To find this, I just Googled RGB color creator, and then I found this one, this W3 Schools. It's got a pretty nice little web app. I'm going to click on it here to open it. All right. And what this lets me do is it lets me create colors here by mixing different amounts of red and green and blue. For example, if I have quote unquote 255 is my red level, and then 0 is my green level, and blue is also 0, I get what's pure red up here. You can ignore all this stuff. These are called hexadecimal codes, which I don't want you to worry about, and I don't even know what the hell this is. But what if I lessen the amount of red and at the same time bring in some green? And it's a little hard to see at first, but as I'm changing and I'm adding green, you might be noticing that that rectangle up there is changing in color. Oh, look at that. It's starting to change to a little bit of orange. It's even more orange now. And if I keep adding more green, look what's happening. It's actually changing to yellow. So if I add a bunch of red and a bunch of green, I end up goofing around with yellow. If I add some blue into it, I start getting other colors. You might notice that color is starting to change up there a little bit hue. I'm going to encourage you at this point, if you want, to hit pause on the video and go mess around with this web page. Here's the address. I'll leave it right here for you. Like I said, I just Googled RGB color creator and I got, this is one of the first few hits I found. I encourage you to goof around with this color picker and start changing the values in R and G and B. In particular, figure out what's the biggest value you can put in and the smallest. So go ahead and hit pause if you want and mess around. If you don't want to hit pause, I'm going to keep going. Okay, so you may have noticed, if you messed around, that the biggest number you can put in any of these spaces is 255. You can't go any higher than 255. That's the max. And you'll notice maybe if you put 255 in each one, that you get a beautiful shade of white up here. And actually white, from what I remember, white is not a color, it is the presence of all colors, which is actually kind of a neat way to think about it. Now, I know what some of you are thinking. If you took red and green and blue paint and mixed them together, you definitely would not get white. You get some like sludgy brown. But again, this is how light is mixed, not how paint is mixed. The smallest values that you can put in any of these are zeros. If you add 0 to all of them, you get black, which is the absence of all color, which is also why, this is going to sound kind of silly, but things look black at night. When there's no light, absolutely no light, no ambient light, no reflective light, things are black. Because what you're actually seeing is you're seeing light reflected back at you. So when you're looking at somebody with a green shirt, for example, that means that that shirt color is absorbing reds and blues and reflecting greens. So when you have no light to reflect, you don't see anything. You can kind of mix colors all you want. If I put 100 in each one, see what I get. I think I'm gonna get some kind of a gray. Let's just see if I'm right. Yeah, kind of a grayish tinge. That's kind of mixing them halfway each. So hopefully you figured out the smallest number for each of these that you can put in is 0, and the highest number is 256. Let's use that and do a little math with that back in the PowerPoint. Okay, so what we're going to do is we're going to try to use the fundamental counting principle to figure out how many possible ways we can mix all these colors together. So see if you buy this. The colors that are possible with a cell phone are going to be, and this is for a computer or for a TV or anything else, it's the number of possible red options times the number of possible green options times the number of possible blue options. So all we got to do is we have to figure out how many red options there are, how many green and how many blue. Well, I think we already did, because there's 256 options. Now, some of you might be saying, wait a minute, Sean, 255. But remember, 0 is an option. So you have to start counting at 0. So 0 is option 1, and 1 is option 2, and 3 is option, 2 is option 3, and 255 is option 256. So starting at 0 and going to 255, there are actually 256 possible red options. There are also 256 possible green options, and there are also 256 possible blue options, which gives us a grand total, if you multiply those all together, of 16,777,216 possible colors that your cell phone screen can show you, which is actually pretty rad to think about. That's a lot of colors. So we will move from cell phone colors to cell phone lock screens next.